Hi friends, welcome to my channel. This is lecture number 29.1. Today we are going to start circuit operation and waveforms of one phase full wave control rectifier with RL load and having freewheeling diode connected parallel to the load. To understand the circuit operation, we have to assume load highly inductive. So when load is highly inductive, it makes output current nearly constant. This is circuit of full wave rectifier. It has 4 thyristors T1, T2, T3 and T4 and it has freewheeling diode connected parallel to the load. Here source voltage is connected between point A and B. So we can write VAB is equals to Vm sin omega t and VBA is equals to minus Vm sin omega t. We will see the circuit operation in 3 angular modes. First from alpha to pi, then from pi to pi plus alpha and at last from pi plus alpha to 2 pi. First start with operation from alpha to pi. Freewheeling diode is reverse biased during this period due to positive polarity of source voltage. Now at omega t is equals to alpha, VAB is positive, which makes thyristor T1 and T2 forward bias. Both thyristors are triggered at omega t is equals to alpha, and after triggering both of the thyristors start conducting. So at omega t is equals to alpha, thyristors get turned on and they will act as short circuit. As soon as T1 and T2 are fired, the current shifts from thyristor T3, T4 to T1 and T2. So the circuit will look like this. Here current will follow the path Vs, T1, load and T2. Apply KVL in this loop. We get V0 is equals to VAB and that is equals to Vm sin omega t. And here source current is equals to I0. You can clearly see this from the circuit. Also, as T1, T2 are conducting, IT1 is equals to IT2 and that is equals to I0. And drop across this thyristor is, these thyristor T1 and T2 is 0. Because both are conducting, means we can write VT1 is equals to VT2 and that is equals to 0. As T3 and T4 are in off state, or we can say that are open circuit, we can write IT3 is equals to IT4 and that is equals to 0. Now apply KVL in the loop having Vs, T1 and T3. We get VT3 is equals to minus Vs, that is equals to VBA. Now apply KVL in the loop having Vs, T2 and T4. We get VT2 is equals to minus Vs and that is equals to VBA. See the waveform. Now from alpha to pi, V0 is equals to VAB, I0 is constant, IS is equals to I0, IT1 is equals to I0, VT1 is equals to 0 and current through freewheeling diode is also equals to 0. Now we will see the circuit operation from pi to pi plus alpha. See, after pi, polarity of voltage, source voltage reverses and it becomes negative. This negative polarity makes freewheeling diode forward bias, so the freewheeling diode get turned on. Now the output current will start flowing through freewheeling diode. So we can say that current start freewheeling in the loop containing freewheeling diode and load. As whole current is shifted to freewheeling diode, so there will be no current in remaining circuit. So we can say that current through T1, T2, T3 and T4, all these thyristors have no current, so current through them is equals to 0 and drop across them, that is voltage drop across T1, T2, T3 and T4 is also equals to 0. Only freewheeling diode current, that is equals to I0, flows. Now see the waveform. We can see that from pi to pi plus alpha, only load current I0 and freewheeling diode current I0 are present. Remaining all parameters are 0. Now see the operation from pi plus alpha to 2 pi. At omega t is equals to pi plus alpha, T3 and T4 are triggered. So T3 and T4 start conducting and act as short circuit because they are already forward bias at omega t is equals to pi plus alpha, and when they are triggered they start conducting. So current will shift from T1 and T2 to T3 and T4. Okay, so we can say that now current through T3 and T4 will be equals to I0, while current through T1 and T2 will be equals to 0. Due to conduction, voltage across T3 and T4 will be equals to 0. So we can write VT3 is equals to VT4 and that is equals to 0. Now this circuit will look like this. Here current will follow the path through this Vs, T3, load and T4. Now apply KVL on this path. We get output voltage V0 is equals to VAB, and that is equals to Vm sin omega t. And here you can see source current is opposite to the load current, so Is is equals to minus I0. We can clearly see this from circuit. Now freewheeling diode current here is equals to 0 because current now start flowing on new path. Now apply KVL in the loop having T1, T3 and Vs. We get Vt1 is equals to Vs, and that is equals to VAB. Also again apply KVL in the loop having T2, T4 and Vs. We get Vt2 is equals to Vs, and that is equals to VAB. See the waveforms from pi plus alpha to 2 pi. So in the waveform V0 is equals to VBA, I0 is constant, Is is equals to minus I0, It1 is equals to 0, Vt1 is equals to Vs, and freewheeling diode current is 0. So this is all about this lecture. I hope you understand all the concepts. If you want the notes of this lecture, then you can write in comment box. I will definitely provide you the notes. And now my next lecture I will upload soon. So thank you. Jai Shri Ram.